All right, yesterday we started talking about an alternate method of dealing with degrees or a degree measure. Yes? Did you print it off? An alternate method of dealing with degree measures. When you're dealing with degree measures, yes, when you're in degree mode, that's what we have done up till now. Okay, throughout your whole mathematical career, whether it's in elementary school, middle school, or high school up to now, you dealt with angle measures in degrees. When you added up the angles of a triangle, they added up to 180 degrees. Our angles of rotations that we dealt with all dealt with the idea of degrees. The problem we run into when we deal with degrees, that starts to fall apart at upper level mathematics. When you get into the calculus world and beyond the calculus world, you have difficulties dealing with degrees. So what we have to do is we have to deal with another method of madness in regards to dealing with degrees. And that's the idea of radians and working with a unit circle. And yesterday when we dealt with the idea of radians, we had a proportion that allowed us to be able to convert our degree radians into theta, or into our degree in radians into theta degrees. So we have pi over 180 degrees is equal to x radians over theta degrees. Now, when you're dealing with the idea of radians, our variable turns into x. When we are in degrees, our variable is still theta. But when you're in radian mode, you can change things into the value of x. Your variable turns into x. Some key ideas is pi radians is equal to 180 degrees. That is a key idea to remember. And degrees is somewhat of our comfort zone, something that you're used to. So when dealing with problems that ask you for the sine, cosine, and tangent of some values of radians, pi over 7, or pi over 4, pi over 3, pi over 6, 2 pi over 3, when you're in the radian mode, put yourself into a comfort zone and change them into degrees. Because when you're in a degree mode, we go back to what we did a month ago in regards to angles of rotation and work with 30-60 right triangles. For your homework today, you had on page 58 and 59, you're dealing with degree measures and you're going into radians and radians into degrees. First section, find the exact number of radians for a degree measure. They give you the degree, you convert it into radians. Very similar to what we did in the notes yesterday. Questions you have in the first section there. How to convert degrees into radians. Once again, leave things in terms of pi. So you're going to have to reduce a fraction down. Now, if you take a look at your calculator, this is a little KYC activity. Yes, I'm an old school person. I'm an old school person that, you know what, it's easier for me to reduce a fraction down by just taking, cancel out a 0 and then reduce your numerator and denominator down. But if you need to fall back onto something, and it is fine, your calculator will reduce a fraction for you, maybe. Oh, hold on. Here we go. If you take away the pi, suppose you had 240 degrees over 180 degrees, 240 over 180, and you want to reduce that down. If you take 240 and divide it by 180, don't hit anything else yet, just type it in there. Hit your math button. Your first option is convert to a fraction. Hit enter, hit enter. It reduces your fraction down for you. So if you have 310 degrees divided by 180, and I need to reduce that fraction down. I can hit my math button, hit enter, and I get 31 over 18. It's a KYC, know your calculator activity here. Know your calculator. Your calculator will do many things for you other than just adding and subtracting. And back in old school ways, that was Tetris. Everybody used to play with it. Your calculator will reduce a fraction down for you if you want to reduce a fraction down. If you're old school like I am, I'm not going to a calculator to do it. I'm going to reduce it down like I typically do. Okay, if you just see zeros at the end, for the one example, you have 310 pi over 180 pi. I can cancel those zeros out, and you have 31 over 18. And hopefully you can mathematically go through and sit there and say, I can't take anything evenly out of both of those numbers, 31 and 18. I'm good to go. Okay, the calculator's there. It's going to take you a little bit extra time to be able to utilize your calculator, but it's there for a crutch if you need it. Section 2, find the decimal approximation for the number of radians. Okay, so you have a decimal approximation. Now you don't want to leave things in terms of pi. So if I take a look at problem number 12. Number 12, you have 258 degrees. And you want a decimal approximation. A decimal approximation. Well, this is our theta value. This is our theta value. So if I take a look at my proportion, I put in my value of theta, 258 degrees, in for theta. You haven't done it, you should be doing it. I put my 258 degrees in for the value of theta. And I'm going to solve for x. Now, when they ask for a decimal approximation to this, now I can use my value of pi. Now I can use my pi button on my calculator. They don't want it left in terms of pi. So I can diagonally multiply. I'm solving a proportion here. Okay, which means I'm cross multiplying and dividing by my third. So I'm multiplying by 258 times pi, then divide by 180. And I can clickety-clack that in the calculator. 258 pi divided by 180. Hit my enter button. And poof, there's my answer. It's like magic. Magic. So when they ask for a decimal approximation, then you don't have to worry about a pi then at that point. 15 to 24, find the exact number of degrees for the angle measure. Now you're given pi there. So what do we do? What do we sub in for pi? 180. We sub 180 in for y, pi, whatever it is. Okay, number 21, 3 times 180 divided by 4. Clickety-clack, clickety-clack. And come up with my answer. And problem number 30. Any questions on putting in value of pi? 180 for pi. Okay, once again, it's just clickety-clack through the calculator. If we take a look at problem 30, find the approximate number of degrees. I'm not worrying about degrees and minutes and seconds. Just give me a decimal approximation. Okay, you have 3 radians. And you want to determine how many approximately number of degrees that you have. So once again, we can go back to our proportion. We can go back to our proportion and sub in our number of radians. And once again, if you haven't done it, you should be doing it. So we have pi over 180 equals x number of radians over theta degrees. Well, I give you 3, you're given 3 radians. So I substitute in my 3 radians. Equals theta degrees. Once again, we are solving a proportion. Bless you. We are diagonally multiplying and dividing by the third value. So we are solving a proportion. Once again, you can use your pi button on this one because they want an approximation. So if they want an approximation, we could just type in we can hit our pi button in our calculator. So we have 3 times 180 divided by pi. Then we hit enter. How many degrees, Abby? 171.8 degrees. Now, let's take a look at a circle here. If I can find one. If we take a look at a unit, no, that's ugly. There you go. Close enough. If we take a look at rotation of what we're talking about here, 171 degrees. 171 degrees takes us to here. Okay? If we would rotate from here to here, once again, how many degrees are we rotating? Kyrie, if we're rotating from here to here, how many degrees? 180 degrees. And in terms of pi, that's what, Braylon? In terms of radians, what would that be? I gave you the answer. 180 degrees is how many radians? 180 degrees is pi radians. This is pi radians. Okay, this is pi radians, which pi is approximately equal to 3.14. Well, what we are dealing with here is 3 radians. 3 radians takes us to here, okay, which is 171 degrees. 3.14 radians takes us all the way down to here, which is 180 degrees. So we should be just a little bit less than the 180 degrees. What I'm trying to do is make the connection here between that value of pi and the 180 degrees and the idea of radians and degrees here. Okay? Once again, radians is the arc length. That is this arc length right here. 180 degrees takes us to this arc length right here, which is pi radians. Okay, which is 3.14. So this arc length from here to here is 3.14. That is the arc length. 3 radians takes us right to here, which is a little bit less than 3.14. So they're trying to, make the connection here between the idea of radians and the idea of degrees. You're going to end up in the same terminal position. Down to bottom. Don't worry about the pi's and the pi's over 2. 33, don't worry about. Let's take a look at 36. Cosecant of 4 pi over 3. We want to calculate the cosecant of 4 pi over 3. Okay, once again, make life easy on ourselves. This changes to a degree mode. Now, one of 2 things. You can Clickety-clack, 4 times 180 and divide it by 3, which is fine. If you want to advance yourself in your mental math, pi over 3 would be how many degrees? Rachel? 180 divided by 3? 18 divided by 3? Add to 0? 6. 6 add to 0, 60 degrees. Okay, take the 18 divided by 3, you get 6. Add the 0, you have 60 degrees. So now we have 60 times 4, 240. 6 times 4, 24. Add the 0, 240. Once again, if you want to advance yourself, mathematically in your mental math. Okay, my first year of teaching, I was up in Lorraine, and I had to teach a 7th grade math class, and we had a book to work from, and the problems in the book said use mental math to solve the problems. It was addition, multiplication, it was mental math, and I thought to myself, what's mental math? Why do we have to worry about mental math? Especially at this level, I'm just worried about, can they multiply this number times this number, and I could care less how they get the result. I want them to be able to get this times this or this plus this. That's all I worried about. I didn't care about if it was mentally or with a calculator or with pencil and paper. I did not care. Okay? I just wanted them to work through the problem. Now when I've got to this level and you've been through all that, that's how you advance yourself in the mathematical world, using the idea of some mental math. Pi over 3, I want to change it in degrees. Well, what's 180 divided by 3? Well, what's 18 divided by 3? That's 6, and I add my 0. So this is 60 degrees. Well, what's 4 times 60? Well, 4 times 6 is 24. Then we add our 0 to get 240 degrees. That's the idea of mental math. That is a lot quicker than you clickety-clacking it through the calculator. 4 times 180 divided by 3. It's a lot quicker. But you can still use a calculator, and there's no shame to using a calculator and find the values. Okay, it's just a way of challenging yourself into the mental aspect of doing things maybe a little bit quicker. So 240 degrees, I want to find the cosecant of 240. Well, we've done this. Oopsie. We've done this problem. Make your axes. Draw in a 240-degree angle. Okay, this should be rekindling some fond memories. Right, Nolan? Yeah. 240 degrees. Where's your terminal side going to be? Okay? Complete your triangle. Chloe, what's 240 degrees? What quadrant are we in? Quadrant number 3. So we're in quadrant 3. We have 180, 240. We have to go a little bit more. Complete your triangle. Throw in your reference angle. Throw in your reference angle. Should be a 30-60 right triangle. So we have 3 values to throw in there. We have a 1, we have a 2, we have a square root of 3. What goes where? What goes where? A 1, a 2, a square root of 3. Check for any negative signs. These are all cues that we did a month ago when we were doing these before. Okay, so hopefully as we go through this a second time, you're sort of, the ideas are sort of coming back to you that we did back a month ago or 5 weeks ago at the beginning of September. That's where organization in your notes also is a nice thing in a 3-ring binder. If you don't quite remember where the 1, the 2, the square root of 3 goes, I can maybe flip back to that page of my notes, and I can find it real quickly. Bryce, what's our reference angle? 60 degrees. So we have a 30-60 right triangle. We have a 1, a 2, a square root of 3. What goes where? Where's the 1 go, Paige? Across from which angle? From 30. From across from 30, we throw in our 1. The hypotenuse, what goes on the hypotenuse, Laura? 2. Which leaves the square root of 3 across from the 60. Sophia, any negative signs? 1 the square root of 3. Okay, now we get to go back and read it once again. This is a lot of recall of what we did. The cosecant is a reciprocal to what, Marley? The sine. Okay, the cosecant's reciprocal to sine. If you get your trigonometric Indian down there, it's fine. Okay. The cosecant is the reciprocal to sine. Sine's opposite over hypotenuse, so we're going to flip that over. Janae, what do you come up with? 2 over negative square root of 3. Hypotenuse over opposite. And then we can rationalize by multiplying top and bottom by the square root of 3. So we have negative 2 square root of 3 over 3. So when going through these problems, and like problem 42, don't worry about the pies. We'll address pies in a different way. If you need to, the pies and pies over 2, you can collect them through the calculator. Any other questions you have? Okay, as I talked about, these right here are the working notes for today. Because what I want you to do is I want you to put a finger on page 59. I want you to put a thumb on 63 and do a pinch. Okay, so you have a finger and a thumb pinching 59 and 63 so you can flip back and forth. On page 59, or I guess bottom 58, problems 1 through 8, tell the exact number of radians in the angles of the given measure. That's 58. Let's now flip to 63, page 63. Tell the exact arc length of the unit circle corresponding to the given angles. Is there any difference between the two problems? If I'm talking about radians and I'm talking about arc lengths, what are they? The same thing. They are synonymous with each other. So if you're dealing with the arc length, you're also dealing with the radians. You're doing the exact same problem, except for they replace the word radians with the word arc length. Section 2 on page 59. I guess we'll go to section 3. 15 to 24 on page 59. Find the exact number of degrees in the angles with the radian measure. That's 15 through 24. Let's now flip to page 63, 9 to 16. Tell the exact number of degrees of the angles corresponding to the given arc length. Is there any difference? No. You are doing the exact same problems. They have just replaced the word radians with the word arc length. You're doing the exact same thing at that point. So our notes that we have for today is just what we did for the homework, because you're basically doing a second day of what we just did. Questions? You have 15 minutes, a little more than 15 minutes here in class. You should be able to get quite a bit of this accomplished here in class. The rest of the time is yours. Yeah, multiples of 3, page 63, 3 to 36 multiples of 3. So that means 3, 6, 9, 12, 15, 18, 20. Just explaining. Yeah. Huh? You do whatever you want with the folders. I would, to me, I'm going to keep my 3-ring binder because I need to reference back. If I need to reference back to something, like we just had to reference back to something, I'm going to keep it until the end. Okay. At the end of the semester, then, you know, when we switch over to stats, then, you know, you clean it out. You do whatever you want with it. They're yours.